Hi, here we go again. Another quick video on domain and range with a few more examples. Let's recall what domain is. We notice that domain again is the set of all x values for which the expression is defined as a real number. And the range is the set of all y values for which is determined by the x values. So that's our domain and range definition. Let's look at a couple examples here. Example number one is the root function. We have the square root of x plus 1. And what we have to do is we have to determine, well, what x values can we put in here to determine if we're going to have a function that is defined or not. Well, what happens is if we set what's underneath the radical, x plus 1, so x plus 1, and we want this to be greater than 0, right? Because if we have anything less than 0, then it becomes undefined because it's a negative under the radical, or it becomes an imaginary number. So we want this to be greater than 0, so we say that x's have to be greater than negative 1. And this gets back to some of the old inequality notation that we're familiar with. And that takes us right here. So x is a negative 1. We plug that in. And once we do, we get negative 1 plus 1 is 0. So we get a value of 0. And then we keep plugging numbers in. 0 is 1. 3 is the next even one that we want. And that's going to be 4. So our domain then is from x is an element from negative 1 included, because we can use the value, to infinity. Infinity not included. The range. Now, as a result, the range is there. So we say that y is an element from 0 included to positive infinity. All right? So everything from in the positive nature. And that's because we have a positive outside the radical. So we want all y values that are positive as a result of this. There isn't any way for us to get a negative in this situation. All right. Final example. Those are rational functions. Yes. A little bit more complex rational functions. Let's say we have the function 1 over x plus 2. First of all, we have to know that we have a vertical asymptote at x equal negative 2. And we get that by just setting the denominator equal to 0. So x plus 2 is equal to 0. Where is that? Because anytime a 0 is in the denominator, it becomes undefined. So we subtract 2, we get x is equal to negative 2, hence the vertical asymptote. Now, we can just start plugging in numbers, and we'll see that a lot of rational functions have this scenario where they're increasing and decreasing as x's either go out to infinity or get closer and closer to this vertical asymptote. So in this case, our domain is x is an element of, go ahead and pause the video and see if you can fill this in before I can, okay? All right, we're back, and check it out. Let's see. Well, do we have any x's that are not included? Yeah, absolutely, negative 2. But let's go out to negative infinity. So we can go negative infinity, unincluded, negative infinity, to what? Negative 2. Not included. Or we're going to have this union here. We're going to start back at negative 2, and we're going to go to positive infinity. So this is an or statement. Or. So do we have negative infinity to negative 2, or negative 2 to infinity. We have to skip over this vertical asymptote. All right, and for the range, are there any y restrictions? Well, the only thing that's restricted here would be 0. So y is an element from negative infinity to 0, not included, right? Union 0 to, and I apologize, my notation is a little bad there, but I'm writing sideways and looking sideways. All right, so y is an element from negative infinity all the way up to 0, where we reach a horizontal asymptote. and then we take back off again, or 0 to positive infinity. And when we have a horizontal asymptote, there's a set of rules that we have to look at and go by, and that will be determined by another video. All right? Thanks. Have a great day. Talk to you soon.